Now we're going to talk about the four-bar linkage. A linkage is a system of links, and the four-bar linkage is a traditional mechanism that we're going to discuss many times in this class in many different ways, which is composed of 4 bars, or 4 links. And I will show you these 4 links right now. So here we have 4 links. And now if you look at these 4 links connected by the 4 pin joints, you might think this clearly looks like 3 links. Well, that's because in every mechanism, including this one, we always have a link that is grounded, which is fixed and does not move, or it moves with a reference point. So we talked about with mechanisms, a windshield wiper is a standard mechanism, and your car can drive around, doesn't stop the windshield wiper from being grounded to the frame of the car. But your frame, which is grounded, can be moved. So let's go ahead, and for this one, we're going to draw that ground just so that we can visualize it. The ground doesn't have to be a straight bar with 2 pins in it. It's just that there's going to be 2 fixed pins, and whatever they're fixed to is considered to be the ground. Now, the other 3 links are called the crank, the coupler, and the rocker. And in the book, they specify that the crank is the one on the left-hand side, the coupler is in between the crank and the rocker is on the right-hand side. And that's because typically the crank is the one that takes an input motion, and usually the rocker is the one that has the output motion. There's going to be some variations of that, which we'll talk about in class. But for the most part, we'll follow the book's metric of having the crank on the left, the rocker on the right. And if you ever see a mechanism where the rocker's on the left and the crank's on the right, walk around the mechanism, and when you turn around, it'll be crank is on the left, rocker's on the right. But we can have that the crank in some 4-bar linkages can do a complete rotation. We'll talk about when that's not the case, but that's where we have our input, and then the rocker will rock back and forth with a motion that moves up, back and forth, and that's why it's called the rocker. So we can define these as crank, our input motion link, the rocker is our output motion link, the coupler is going to be the moving link that connects the rocker and crank, and the ground is going to be the fixed link that connects the rocker and crank. And we're going to talk about how we can use SolidWorks in order to help us synthesize links. So one of the fun things that we're going to do, and why this course is not just theory but also a lot of lab, and why you'll be able to do a design project, is using something called graphical linkage synthesis. And in this case, graphical means relating to computer, relating to computer graphics, and we are going to use SolidWorks to create this. You can use other softwares as well. And the synthesis means that we're combining components to form a system. So we're selecting the lengths of links. We're going to determine how long they need to be, where their connection points need to be, but we're essentially working with the links. So it's not pure free-form design because we're working within the context of a linkage, but we're still synthesizing a new solution. So we're going to take a desired 2 to 3 positions of either our rocker, our crank, our coupler. For most of the examples today, it's going to be the rocker, then it's going to be the coupler for a few others. And so I'll look through our first one. So here we have 2 positions of the rocker. We're going to do this example in class, and your book goes through this example in a lot of detail. But we can say we want to reach those 2 points with our rocker. Start at one, finish at the other, and then go back. Rock back and forth between those 2 positions. And what we can now do is, if we put this in SolidWorks, we can use geometry to place links. So I'm going to see if I can press and pause. So between the links, we might find the midpoint, create a line from that midpoint that extends out long enough, and then create a circle that can fit over those 2 endpoints with the midpoint as its center. And we're going to create that circle also same size on the two lengths. And we know that the reason why we're doing that circle is because when we have the crank at its farthest most position, it will reach the longest, furthest out point of the rocker, and when it rotates the other way, it reaches the other way of the rocker. And then we could place our rocker. We could redraw that using those three links at that same connection point. And then we can start to place the linkage within the context of what are we using this design for. So here, if we have this linkage that's moving back and forth, but it's in a factory environment with a little robot, we can use this wireframe to make sure that the other components aren't getting hit. So here we have a little robot. We don't want him to get hit by the coupler, so hopefully it rotates entirely around him. Then if we meet our basic wireframe needs, we can then go ahead and create a 3D model, combine the 3D models of the different links into an assembly, and make sure that it meets our design needs. So I'll have a demo in class for this, but that's the theory and the rationale behind it.